imagine a world where one nation held the ultimate, the most terrifying power known to humanity.
Mm-hmm.
And then almost overnight, that power balance was just irrevocably shattered.
Yeah, completely changed.
It wasn't just a shift. It was, well, an earthquake that fundamentally reshaped the 20th century and the geopolitical landscape we still navigate today, really.
Exactly. And today, we're diving right into that precise moment. We're going to unravel the story of Fat Man, the atomic bomb that set this terrifying precedent.
That's right.
And its near-exact Soviet twin, Joe-1, the weapon that didn't just ignite the Cold War's nuclear arms race, it basically poured gasoline on it, accelerated it into a full-blown sprint.
Okay, so our mission on this deep dive is to unpack the incredible engineering behind these devices.
Yeah, the tech is fascinating.
And the intense political pressure that drove their creation and, well, the shocking role of espionage that dramatically compressed history.
It really did.
We'll explore how these two bombs, separated by just 4 years, defined an entire era. Get ready for some surprising insights and a deep dive into the dawn of mutually assured destruction.
Let's get into it.
So, before we can truly appreciate the Soviet breakthrough, we have to grasp the original marvel, or maybe terror is the better word. That was the Fat Man bomb. This was the second atomic bomb ever used in warfare, detonated over Nagasaki, Japan, August 9th, 1945. What kind of engineering beast was it exactly?
Well, the Fat Man was a monumental achievement in, let's say, destructive engineering, unlike its simpler predecessor, Little Boy.
The Hiroshima bomb.
Right, which was a gun-type device, relatively straightforward, where you fire one piece of uranium to another.
Okay.
The Fat Man was totally different, an implosion-type nuclear bomb.
Implosion, so squeezing something.
Exactly. It used conventional explosives, very precisely shaped, to symmetrically compress a core of nuclear material inwards, making it super dense, super critical, and triggering the chain reaction that way.
That sounds much more complicated.
Oh, vastly more complex, and much heavier, weighing over 10,200 pounds, 128 inches long.
Yeah.
And that gave it that distinctive kind of wide, round shape.
So it wasn't just heavy for the sake of it. The complexity of that implosion mechanism really drove the design.
Absolutely.
And at its core was this intricate implosion sphere. What was actually happening inside that incredibly engineered heart? Can you walk us through that?
Yeah, it was a marvel of precision, really. Picture this. It started with 32 precisely arranged blocks of high explosives.
32. Wow.
Yeah, and carefully layered, too. Faster detonating ones, slower detonating ones, all designed to create this powerful, perfectly symmetrical inward pressure.
Like a perfectly controlled inward-directed explosion.
Exactly. This shockwave then hits an aluminum pusher.
Okay.
Which then compresses a uranium tamper made of uranium-238.
Right, a tamper made of U-238, which isn't the main fissile material like the plutonium. What was its crucial role here?
Well, the uranium-238 tamper served two really critical functions. First, it acted like a powerful vice, confining the implosion, ensuring the core reached maximum density, squeezing it tight.
Right, holding it all together for that fraction of a second.
Exactly. And second, crucially, it reflected neutrons back into the pit.
Accelerating the chain reaction.
Precisely. And what's truly astonishing is that this tamper itself wasn't inert. It actually underwent nuclear fission, too.
The tamper itself fissioned.
Yeah, contributing about 30% to the total blast yield.
30%? That's huge.
It is. And at the very, very center of all these layers, that's where you find the plutonium pit, plutonium-239, the actual fuel for the chain reaction.
That's a lot of carefully orchestrated pieces. But the true genius, or maybe terror, again lay in how they kicked it all off. How did they ignite this inferno with such exquisite precision?
That's where the Urchin neutron initiator came in. A tiny, ingenious device.
The Urchin.
Nestled right inside the plutonium pit. It contained polonium and beryllium.
Two different elements.
Right. Separated. When that colossal implosion crushed the pit, it also crushed the Urchin.
I see.
Mixing these elements instantly, releasing a sudden, powerful burst of neutrons.
And those neutrons are the trigger.
They're the spark.
Yeah.
They bombard the now super-compressed plutonium-239 atoms, causing them to split, release more neutrons, more energy.
And boom, the chain reaction.
The chain reaction. Culminating in that violent explosion. It's a testament to incredible foresight and engineering.
And this entire intricate dance had to be executed with perfect timing and altitude for the best effect.
Right? Absolutely. Precision was everything. The detonation was carefully choreographed in 3 stages.
3 stages.
Yeah. A timer to start the sequence.
Okay.
A barometric device to measure air pressure, basically for altitude.
Right.
And then a radar altimeter for fine-tuning that height.
Making sure it went off at just the right spot above the ground.
Exactly. About 500 to 590 meters up. This aerial burst maximized the blast wave and the thermal radiation on the target.
And kept the plane safer too, presumably.
Yeah. And kept the plane safer, yes. Then, an electrical firing set, the X5 unit, sent impulses simultaneously to all 32 detonators.
All at once.
Precisely. Initiating that perfect implosion.
Incredible precision for such a, well, destructive device. The Fat Man ultimately yielded 21 kilotons of TNT equivalent. What was the physical impact of all this on Nagasaki?
It leveled everything within a radius of up to 2 kilometers. Just flattened it.
2 kilometers?
Yeah. Interestingly, though, it caused somewhat less damage overall than Little Boy did in Hiroshima.
Really? Even though it was technically a more powerful yield?
Yes. Primarily due to Nagasaki's geography. It's quite hilly.
Ah, so the hills offered some shielding.
Exactly. Shielded parts of the city. Hiroshima was much flatter, so the blast waves spread more uniformly.
Makes sense.
And as a final layer of sort of fail-safe engineering, if the aerial detonation failed for some reason, 4 AN-129 impact fuses would detonate the bomb upon hitting the ground.
So it wouldn't be a dud that could be captured.
Precisely. Preventing its secrets from falling into enemy hands.
Okay. So the U.S. had this incredibly complex, world-changing device, the Fat Man, securing a brief, terrifying nuclear monopoly.
A very brief one.
The world was forever changed. But then, only 4 years later, the Soviet Union detonated its own atomic bomb. Years ahead of what Western intelligence predicted.
Years.
How on earth did they bridge such a massive technological gap so quickly?
It was an astonishing acceleration, really. And it was driven by, well, desperate urgency.
Before 1945, their program was pretty small, right?
Very nascent stage, largely theoretical, limited resources. Some findings were even published openly in journals, believe it or not.
Wow.
But the atomic bombings of Hiroshima and Nagasaki in August 45, that was an incredibly powerful catalyst. Joseph Stalin was absolutely galvanized.
He saw the threat immediately.
A direct existential threat. The U.S. nuclear monopoly wasn't just a strategic advantage. He saw it as a threat to Soviet security, their global standing. This wasn't just about power projection. It felt like survival.
So Stalin essentially pushed the button on an all-out, no-expense-spared crash program.
Exactly that, an all-out crash program. He put it under dual leadership.
Dual.
Yeah. The physicist Igor Kurchatov, often called the father of the Soviet bomb, he was the technical director.
Oh, right, the science guy.
Right. And Lavrenti Beria, the ruthless head of the NKVD, the secret police, as the political overseer.
Beria. That sends a chill down your spine. He wasn't known for patience.
Not at all. He was infamous for his brutality. He created an environment where failure was simply not an option. The pressure was immense.
And faced with this monumental task and that kind of pressure, the Soviets made a very specific strategic choice, basically to copy the Fat Man. What does that decision tell us about their priorities? Was it pure pragmatism or maybe something deeper about the Cold War starting?
I think it was pure, raw pragmatism driven by that political urgency. Get it done now.
Even though their own scientists were working on design.
Yes. Soviet designers had independently developed a potentially more sophisticated implosion design. But Beria insisted, absolutely insisted, that Joe-1 be an exact copy of the Fat Man bomb that the U.S. dropped on Nagasaki.
Wow.
It highlights the absolute primacy of political expediency over maybe scientific innovation at that moment. The goal wasn't the best possible bomb. It was a guaranteed working device, and they needed it fast. Like yesterday.
And this is where the espionage story really kicks into high gear. They got help.
A lot of help.
Providing them with what basically amounted to a very detailed instruction manual, didn't it? This wasn't just like general intelligence.
No, this was the roadmap. The remarkable speed of the Soviet project was significantly enabled by a sophisticated and, frankly, highly effective espionage network.
Inside the Manhattan Project itself.
Right inside. Penetrated it successfully. This effort quite literally shaved years off their development timeline. They weren't guessing. They were getting key answers, not just hints.
So who were the key players? What were the absolute critical pieces of the puzzle that spies like Klaus Fuchs and others handed over? What truly accelerated their journey?
Fuchs. Klaus Fuchs, a German-born theoretical physicist working at Los Alamos, he was the big one, the most significant contributor.
What did he give them?
He didn't just give them, like, a single blueprint. He provided what amounted to a comprehensive technical package, a de facto manual.
A manual for the bomb?
Pretty much. It included detailed sketches of the bomb's layout with dimensions, extensive information on implosion theory, the components, specifics on the Urchin neutron source.
Which he helped invent for the U.S.
Exactly, which he helped invent. Critical data, like the critical masses for plutonium-239 and uranium-235.
Defining critical mass again.
Oh, right. Critical mass is the minimum amount of fissile material, like plutonium or uranium, needed to sustain a nuclear chain reaction, vital information.
Absolutely.
And he even provided crucial plutonium metallurgy data, including the solution of using a plutonium-gallium alloy.
Why was that important?
Plutonium is tricky stuff and changes phases, density. Alloying it with gallium stabilized it, made it easier to machine and work with for the pit. That was a huge hurdle the Americans had to overcome, and Fuchs just handed them the answer.
That's an astonishing level of detail. It's almost like giving them the full schematics and the operating system.
It was invaluable, absolutely invaluable. And there were others too.
Right, not just Fuchs.
No. An American theoretical physicist, Theodore Hall, he provided detailed descriptions of the Fat Man and also plutonium purification processes.
More key technical details.
And a machinist, David Greenglass, he offered crude sketches of the high explosive lenses, those shaped charges we talked about.
Even crude sketches would help confirm things.
Definitely. Plus careers like Harry Gold, and maybe others we still don't fully know about, like Oscar Seebohrer, who was identified more recently. This network was incredibly effective. It answered problems that would have taken the Soviets years of trial and error to figure out on their own.
It's striking, though, that despite having this, treasure trove of intelligence, the Soviet leadership didn't just blindly copy it.
No, they were cautious. Or maybe paranoid.
What kind of verification process did they undertake? What did that reveal?
Well, initially, Soviet leadership, including Kurchatov and even Beguria, they harbored fears. Could this be disinformation? A trick?
A reasonable fear, I suppose.
Absolutely. So they insisted their scientists retest everything themselves, double-check the math, redo the experiments.
Yep.
But by cross-referencing their own theoretical work and their own lab results with Fuchs's incredibly detailed data, they could quickly confirm their trajectories.
So it validated their own work, too.
Exactly. It eliminated years of potential dead ends, blind alleys. It gave them the confidence to proceed full steam ahead with a proven design, rather than starting from scratch or maybe pursuing less efficient paths they might have otherwise explored.
And beyond the espionage, were there other factors that sped up this monumental program? It wasn't just the spies, right?
No, not entirely. Other factors definitely played a role. The Soviets also shrewdly utilized, captured German scientists and resources after World War II ended.
Operation Osowieckim, essentially.
Something like that, yes.
Yeah.
Specialists like Manfred von Ardenne, Gustav Hertz, Nobel laureate, they contributed significantly, particularly in areas like isotope separation, which is key for uranium enrichment and uranium metallurgy.
Leveraging expertise wherever they could find it.
And crucially, securing the raw materials.
Yeah.
Uranium.
Right, you need the fuel.
They secured crucial uranium sources from territories they now controlled or influenced. Mines in East Germany, the Sag-Wismut operation was massive. Czechoslovakia, Tajikistan, places like Tashar, Bulgaria, Poland.
And the labor for that.
Often, tragically, extensive gulag labor was used for the mining and the immense construction projects needed, a huge human cost behind that speed.
And they built their entire nuclear infrastructure basically from the ground up, even while the country was still reeling from the devastation of the war. That's a massive undertaking.
It really was. Key facilities sprang up. The secret city of Artemis 16.
Their Los Alamos.
Their Los Alamos equivalent, exactly, where Yuli Kiridin led the bomb design team. The Kurchatov Institute in Moscow, Lab Number 2, was central for research.
Okay.
And the Mayak Production Association, Chelyabinsk 40, another secret city, was built specifically for plutonium production.
That's where they made the fuel for Joe-1.
That's right. They achieved Europe's first self-sustaining nuclear chain reaction at the F1 reactor near Moscow in December 1946.
A huge milestone.
And the A1 plutonium production reactor at Mayak was operational by mid-1948, providing that vital plutonium for the first Soviet bomb. Things moved incredibly fast once the decision was made.
So all this intense effort, the copying, the espionage, the captured scientists, the immense labor, building everything from scratch, it all culminated on one fateful day. Tell us about the first Soviet atomic test. What did it signal to the world?
August 29, 1949, 7 a.m. local time. The Soviet Union successfully detonated its first atomic bomb.
The end of the American monopoly.
Instantly.
Yeah.
Officially, the device was designated RDS-1. Internally, though, they codenamed it First Lightning, Prvaya Molnia.
First lightning. Quite evocative.
It is. But the United States, when they detected it, famously assigned it the codename Joe-1.
A direct, maybe slightly mocking reference to Joseph Stalin.
Exactly.
Joe-1 stuck.
And where did this historic and, for a short while, secret event take place?
It was detonated at the Semipalatinsk test site in the Kazakh Soviet Socialist Republic, now Kazakhstan.
Okay. And the device itself?
It was, as intended, an implosion-type weapon, just like the Fat Man. Even similar in physical appearance, apparently, with its solid plutonium core.
And the yield? Did it match?
Almost perfectly. Its yield was measured at 22 kilotons. Fat Man was 21 kilotons, so right on the money.
Wow.
In fact, Soviet engineers later calculated it was actually 50% more destructive than their initial estimate suggested it would be.
More powerful than expected. And for the test itself, they studied the effects closely. Well, yes. They built houses, bridges. They even placed animals near ground zero to study the devastating effects of the blast, the heat, the radiation. Very thorough.
The Soviets certainly wanted to keep this achievement quiet, at least for a while. How did the U.S., thousands of miles away, even discover this secret test had happened?
That's a fascinating story in itself. The U.S. had a top-secret program called the Interim Surveillance Research Net.
Catchy name.
Yeah. Run by the Air Force Office of Atomic Energy, AFO-AT-1. They used specialized WB-29 weather reconnaissance planes. Basically, superfortresses kitted out with special filters to collect air samples.
Sniffing the air for radiation.
Essentially, yes. On September 3, 1949, just days after the test, one of these planes, flying a route off the coast of Siberia, collected air samples showing abnormal radioactive contamination.
The telltale signature.
Unmistakable signature, consistent with a nuclear explosion. This crucial intelligence was codenamed Vermont, and it was undeniably accurate.
The impact on American intelligence and really the U.S. psyche must have been a profound shockwave, a complete blindsiding.
Oh, absolutely. A profound shockwave is the right term. It was considered a truly disturbing failure of U.S. intelligence.
Because the predictions were way off.
Way off. Analysts had projected the Soviets wouldn't get the bomb until 1953 at the earliest. Some estimates even went out to 1954.
So, years ahead of schedule.
Years. The test occurring so much sooner was a massive blow. It revealed a significant miscalculation of Soviet capabilities, their determination, and, critically, the effectiveness of their espionage network.
And President Truman, faced with this new stark reality, made a public announcement that really changed everything.
He did. On September 23, 1949, President Harry S. Truman went public. He announced, quote, "We have evidence that within recent weeks an atomic explosion occurred in the USSR."
It must have surprised the Soviets.
It absolutely did. They'd hoped to keep the test a secret for longer, maybe use it for diplomatic leverage later. Truman's announcement forced their hand and marked a definite, irreversible turning point in the Cold War. The secret was out.
So, if we connect all this to the bigger picture, what did Joe-1 ultimately mean for the world? How did this one event fundamentally change the trajectory of the 20th century?
Well, fundamentally, the Joe-1 test instantly ended that brief 4-year period of American nuclear monopoly, 1945 to 1949. That was it.
And the U.S. reaction was immediate.
Immediate and decisive. This loss of monopoly directly led President Truman to order the acceleration of the U.S.'s own next-generation weapon program, the hydrogen bomb, the super.
A weapon potentially hundreds of times more powerful.
Exactly, a terrifying escalation. This decision officially kicked off the full-scale nuclear arms race. Both superpowers were now locked in a desperate race to develop and stockpile increasingly devastating weapons.
So Joe-1 really lit the fuse.
It did. More than any other single event, you could argue, Joe-1 solidified the nuclear standoff between the two superpowers. It set the stage for decades of strategic tension, proxy wars fought under the nuclear shadow, and this new, chilling era defined by the concept of mutually assured vulnerability, or MAD, mutually assured destruction.
The balance of power shifted overnight.
Completely. It deepened mistrust, hardened the already forming Cold War divisions, and established the era of nuclear deterrence that, arguably, we're still grappling with the legacy of today.
What an incredible deep dive. Just laying it all out like that, from the intricate engineering of the Fat Man.
Amazing piece of work, technically.
To the politically driven replication, the copying, and that shocking espionage behind Joe-1. We've really seen how a few short years and, well, a handful of key figures ignited a global arms race that defined generations.
Yeah, the story of Fat Man and Joe-1 isn't just about bombs, is it? It's really about the unforeseen consequences of scientific discovery.
Right.
It's about the relentless pursuit of power, national security, and just how quickly the world can transform when political will meets technological capability.
And crucially, intelligence. Espionage.
And espionage, absolutely. It's a stark reminder of how a single event, a single technological leap or copy, can shift geopolitical plates and establish a dangerous, yet in a strange way, stable, strategic standoff for decades.
It leaves you with a lot to ponder, really, this whole deep dive. I mean, what if the Soviet bomb project had actually taken another 10 years, like the initial predictions?
That's a huge what-if.
How would that balance of power have shifted without that immediate or near-immediate parity? And maybe more relevant for today. What lessons does this rapid scientific catch-up, fueled so heavily by intelligence, hold for the technological races happening right now? You know, in AI, cyber, biotech, where speed, information, and maybe even intellectual property theft are just as critical as they were back then.
That's the lingering question, isn't it? History doesn't repeat, but it certainly rhymes.